The topic of today's presentation is antibody discovery pipeline. So until last week, I've been explaining about how we are building the vaccine development pipeline, which is under the Infectomics project as well. And today I want to go around explaining what is happening about the antibodies. The objectives behind the antibody discovery pipeline are as follows. First is to extract the antibody sequences and check variants from transcripts of the virus-infected patients. Second is to predict 3D structures of antibody sequences. Third is to actually construct the library of antibody structures of infected and non-infected patients. And the last is to actually propose the structure of the therapeutic antibodies, which is our goal. The workflow of the pipeline. I'm pretty sure I've shown you this earlier this year, and I've actually gone through some major revision and revamped the pipeline again. So first we start off with the RNA, raw transcripts in bulk. Then we extract the antibodies using two tools, either of the tools actually, Trust and Mixer. And we detect the variants or somatic hypermutations using ImmuneArc, and we'll go the usual 3D modeling the proteomic analysis downstream to find the hit, which is the therapeutic antibody. And this part is what's going through right now. Explaining briefly about the license information for these tools, Trust4 and ImmuneArc allow for an open source use. However, Mixer explicitly prohibits commercial use without permission. So its use requires license code bundled with the purchase. So I think it's unlikely that we proceed with Mixer. That we cannot use the Mixer but only Trust, there's a problem. The Trust is only partially compatible with ImmuneArc. The output currently has a few missing columns, which leads ImmuneArc to raise errors such as no data in mandatory VN column and sample reports. This was devastating to me, as I've been working 2 full days or a few full days to find out what's going on, why the ImmuneArc wouldn't allow for the reports, the Trust report, to be analyzed, and I've actually found that the columns are actually NA or missing. And we are unable to further proceed with checking variants as a result. And the checking variant part is important, as I will explain later. There is a solution to this, however, which is to parse from anode's FASTA file. The missing information is actually contained in the supplementary data, the FASTA file, which is a bit organized, as you can see over here, and we will have to build a separate parser ourselves, which will take a bit of the time. Fortunately, there is a yet second problem. Even if we get Trust and ImmuneArc fully working together, ImmuneArc itself is actually unable to detect variants with our own data. So first of all, discovery of variants is very important for selecting antibodies with high affinity towards antigens. So what I'm saying is that if you see the figure over here, there is a germline or the original B-cell receptor or antibody sequence over here, and this sequence rapidly undergoes mutation as well as selection process within lymphoid organs to produce the children or child clones of the antibody or the BCR. And those antibodies will supposedly have higher affinity towards the antigens, since they've undergone the mutation and have learned, like machine learning, they've undergone natural learning of what is the best fit, what mutation causes the best fit against the antigen. So supposedly or theoretically, as more mutation they have undergone, they should have higher affinity towards that antigen. And as you can see, these are the variants that a specific clone has against the germline and respective mutation rate. And these figures are actually very important and are able to be obtained through ImmuneArc with their test input data. Problem is that we are unable to produce the figures and statistics at the moment. What's happening is that the tools cannot detect sequences that can be aligned together. So the tool is actually using the cluster omega in order to align these sequences, the cluster of sequences together, but they cannot detect anything. And we suspect the sequencing depth might be the problem, and this is unresolvable since we already have the data and we cannot produce any more data. And you can see that by this tables over here, these tables over here. First one is the test data that ImmuneArc presents, and you can see that the first clone has around 15,000 clones within it. And this is our data, which only has around 3,000 at best. So I think that's why it's not working. Kind of in a sticky situation. A possible solution would be replacing ImmuneArc altogether with in-house script, reinventing the wheels approach. So just simply replacing ImmuneArc with in-house script would be one possible solution, but would it actually work as yet another problem? So that was it. Thank you.